It's a tragedy that rocks St. Louis. More than 2 years ago, 4 people were killed and 3 people were hurt after an early morning boiler explosion in Soulage.
I was just clocking in and this boom, and I was on the ground. I didn't know what happened.
Ronnie Brooks survived that day. One of his co-workers at Loy Lang and 3 people in a business down the road died. The nearly 2,000-pound part crashed through the roof of faultless healthcare linens at roughly 120 miles per hour.
The CSB found that Loy Lang's management did not understand the hazards of its operation and did not see a leaking pressure vessel as a safety emergency.
It's at this part where the laundry list of faults comes out.
The company failed to prevent corrosion in the SCR, had no inspection program, never investigated or addressed the root cause of the corrosion in its steam system, and repeatedly operated the SCR while it was leaking, including on the morning of the explosion. Therefore, the CSB concluded that Loy Lang did not employ sound safety management principles in addressing the risks associated with corrosion in its steam system.
A source close to the investigation says this is a more than $47 million global settlement reached between all of the plaintiffs and the defendants, and that this agreement settles the nearly 10 different lawsuits that were all born out of this deadly blast.
The High Fire Podcast is your go-to for straight talk on the steam and boiler industry. Get knowledge you can use, stuff that matters, like tech, safety, industry trends, and more. Whether you're an engineer, a tech, or a plant manager, we've got the info that matters to you from steam industry experts. Tune in and stay fired up. What does it look like when preventative maintenance gets pushed aside? In this podcast episode, veteran professionals talk through the cascade of failures that led to the deadly explosion in St. Louis and how industry leaders can build a culture of safety that actually works.
We are going to be talking about really a tragic incident that happened, and this was actually just because preventative maintenance, was kind of an optional situation. And when we're dealing with pressure vessels, in our line of work and many others out there, we all know how dangerous these things can be. And this particular one this is about the Loy Lang Box Company, where they had the explosion. It was actually a semi-closed receiver. And Bill, maybe you could just kind of give a little bit more insight on that as far as just what happened with that pressure vessel.
Yeah, so in the box board industry, where they're making, boxes like this, corrugated boxes, they use high pressure steam to form these little corrugations. And they have a drum that has these corrugations in it. It's called a former. And they put 150 pound steam in that drum. And it has to be very hot in order to retain that shape. And then they take that high pressure condensate that's about 350 degrees, 125 PSI or so. And it goes directly back to the boiler ware into a high pressure receiver, which is kind of unusual for use of steam. Most of the time, the condensate returns at a much lower pressure and much lower temperature in most industrial applications. There's only, I think, around 600 or 700 people that have this actual process. So normally in a condensate receiver, you don't have that much stored energy. But it doesn't mean that in a condensate receiver that's running at atmospheric pressure that you still can't have it explode. That still happens. Low pressure receivers still explode. But that's what provided the force to send that 2,000 pound tank through the roof. Was that additional energy, stored energy. There was about 158 BTU more per pound of energy in that high pressure condensate than what there would be at atmospheric conditions. So when that leak began and eventually broke open, all that energy came out at once. And so that's what was unique about this situation. Yeah, but they do that in this industry because they want to bring the condensate back as hot as possible, and then they don't have to reuse that energy. They don't have to recreate that energy.
Gerald, what actually happened, and what did they find that was really the cause?
Well, the vessel itself had been neglected for years and years. I mean, it even had some poorly done repairs where they didn't get all the rusted elements out of the bottom of the tank when they repaired it before. Mm-hmm. So they had good material up against bad material, and over time it just let go. And when it lets go like that, we're talking about 1,600 time release in a matter of a second, which is where all that force comes from. And it's interesting, too, that people should realize that, oftentimes it gets confused and they'll say, oh, there was a boiler explosion. There's very rarely boiler explosions. They do happen, but they're very rare. Mm-hmm. But there's an abundance of explosions with non-fired vessels. And I don't know if it's because they don't really have many moving parts. They don't make a lot of noise until there's an explosion. They get overlooked.
Right, right.
So,
one of the things that it did talk about is there were some clear warning signs. Maybe you talk a little bit about that, Lane.
So they were having leaks, and they'd called a company to come out and service it and try to assess it and make a repair to it, which it was the right thing to do. The wrong thing was to keep on running. And because that company couldn't get there right away, I think they had them scheduled for the next week.
Yeah.
And they elected to keep on running it. Not realizing, the potential danger that they had there. I'm sure, hindsight's 20/20, but they had no idea, the potential danger that they were dealing with.
And I think that's what they run into is they're like, oh, it's been leaking for years. Mm-hmm. Well, it's fine until it's not fine.
Yeah, yeah, yeah. I mean, this was a 2,000-pound vessel, and it launched 500 feet away from. I mean, incredible.
Yes, incredible amount of force.
Like Daryl said, steam expands 1,600 times whenever it hits atmospheric pressure. But one thing I thought was a little unique about this, a lot of times tanks are on their side compared to the way this was, where your heads, would be going sideways. Doesn't mean it can't launch upwards, but in this case, the tank was set vertical. So when the head separated, it was literally a rocket. I mean, that's how it was going to go out the building. It was like a rocket, and that's exactly what it did.
It was constructed for launch mode.
Yeah.
And it definitely launched.
But it's not unusual in that industry. I mean, several of them where they've had leaking, those vessels leaking. And a lot of times they're in combination with the deaerator, the high pressure receiver on one side, the deaerator, and going in, seeing them leaking. And I'm like, whoa, guys, you need to shut down. And rarely do they ever do because they just don't understand the amount of stored energy that's in that high pressure condensate. It's incredible.
Right. Yeah. And what's going on the inside is maybe not what it looks like on the outside.
Right.
Where that corrosion starts happening.
Right. Well, it was interesting too. They had along the way they had their makeup water tank. They were having problems with corrosion there, and so they made the decision to make it stainless. And I've seen this happen numerous times where people want to put in a stainless deaerator and so forth, and all they're doing is masking the problem and kicking it down the road. It's going to affect something else once it's not affecting this.
Sure.
So not addressing corrosive water issues and so forth are just an absolute no-no.
Yeah, right. Yeah, you definitely want to keep that in top of mind for sure. Why don't, real quick, Bill, this is your first time on the podcast. Why don't you introduce yourself, if you don't mind, and kind of what you've been doing with WARE?
Yeah, my name is Bill Fogarty. I'm the valve division manager. I get involved, not so much in the boilers itself, but everything beyond the boilers. Steam delivery system and condensate return.
Yeah, and you are coming up on retiring.
Yes.
Which is cool.
84 days.
84 days. 2 hours. 6 minutes. That is awesome. And you've been with us a little while, but you've been in the industry for a pretty good number of years. Lots of wealth of knowledge and experience. We certainly appreciate all that you have brought to the company with all the experience and finding solutions and pointing out things that could possibly keep people from having some catastrophic stuff. So, Drew.
Yeah, I've been on the show before, but I'm the vice president of our projects and services division. Been here going on 22 years now. So.
Yep.
I'm Nathan Cates. I've been on here before, but service manager here at Louisville, and I've been as a service technician before, and I've been here for just over 9 years.
Yep. Just starting to break him in. He's getting used to the camera a little bit, which is good. So you've obviously seen Gerald quite a bit on the boiling points that are out there. So little plug. Make sure you check out our YouTube channel. But let's talk. I guess this actually was a settlement from a lawsuit at this particular plant that was north of $40 million. But probably the most tragic thing is that there was loss of life in this situation that didn't need to be. Just doing some general maintenance. So really, what we go to next maybe is just some actionable items that professionals can actually implement based on this. And really, it just starts first with conducting a regular internal and external inspection. Right? Maybe expand on that, Bill.
Yeah, condensate is corrosive by nature. And if it gets oxygen in it, it's particularly corrosive.
Here, Hillary.
And one of the things to look for, if you have pitting at the top of a condensate pipe, okay, that's the presence of oxygen. You don't see it very often, but you'll see it in systems that are not used continuously. They're on-off, maybe shut down on the weekend. And oxygen will get into the condensate receiver. It'll oxygenate the water, and then when you start it back up, it pumps it into the condensate return system. And I've got a sample pipe here that this customer kept replacing. This pipe only lasted 3 months, and on the inside of it, there's a big pit. And it was actually leaking out of the top of the pipe. So if you see that happening, that's the absolute sign that you've got oxygen in your condensate return system. So what the customer was doing was gradually replacing it with stainless steel. And to Gerald's point, all they were doing is moving it down the road. And they were moving it. It was going back to a condensate receiver in the boiler room, which eventually started having problems. So that's one thing you can look for. Most condensate pipes will rot out to the bottom, but if you see pinhole leaks appearing at the top, that's a very definite sign that you got oxygen in your system.
What happens, or actually, how do you get oxygen out of the system then?
Well, one way you can prevent it from getting in the system is always keep a little bit of steam on that condensate receiver. Okay, so you're just going to keep a little positive pressure in there, 1/4 of a PSI or something, just so oxygen can't work its way back in. But if you have a system like that that's going to pick it up, then you have to run it back to the deaerator. And it's got to go in with the makeup water to be deaerated, not returned to the receiver itself.
Okay. What about to actually help the process? Is that, is there anything that should be scheduled to really make sure this is not happening?
Well, most of our customers, the industrial customers that they are, usually have all these vessels inspected annually. And I'm not sure, what is the DA schedule?
5 years.
5 years, but most of them open them up every time they have a shutdown.
Right. Are they investigating thickness in that situation every year?
You're looking for signs
Or just pitting?
Yeah.
Okay. But actually scheduling some times that, could actually look at thickness testing is something that, can be done, obviously.
You can, if you have a lot of corrosive look to it, that's when you start thinking about that.
Right.
Yeah.
Right. Okay. What type of instrumentation would be used in that situation?
So we've seen a big push here lately, not just to have the DAs inspected, just to open up and take a look, but the insurance companies, requesting non-destructive testing done. where they'll come in and they'll do the ultrasonic, they'll do different types of non-destructive thickness testing to determine if there's any weak spots or anything like that. They're going to the seams and to the heads right away. That's the first thing that they want to take a look at. And that's what we have, the experts come in with those instruments to come do. We're taking a look just overall at the vessel, see if we see any pitting, things like that. But then we're also taking a look at the tray system, or taking a look at the nozzle, whatever setup it has internally. We want to make sure that, everything's in there. It's not uncommon to open one up and find the nozzle, laying in the bottom. And some new customers that we went to, it's not uncommon to find where they've brought their condensate back, but didn't bring it into where the feed water enters. They just brought it straight into the tank. So then it doesn't go through the deaeration process. They thought they were doing everything the right way, but all you got to do is bring it back to the wrong port, and it's not going to go through the deaeration process.
But they should still know that, regardless. If they don't know it, they're not checking their water.
Right.
If you check your water and the numbers are wrong, something's wrong. And you see a lot of times things get pencil whipped if they check it, and then a year later, their equipment is failing, and they're like, "Oh, we've been checking it. Now we've been just writing on this piece of paper."
Yeah.
You actually have to do it.
Yeah, which really brings it down to, something I know that we talk a lot about, and that's preventative maintenance. To where you have preventative maintenance, and it's not just a word, but there's an action that actually, goes with that. Maybe talk about preventative maintenance, Bill, and what you would be doing in that preventative maintenance schedule.
Well, the first thing you do is on the way back to the deaerator or feed water heater, look for signs of corrosion occurring. And that's the earliest warning sign you're going to get. So that's, walk the system down, look for those kind of things. On preventive maintenance on the deaerator, you should be opening up periodically, checking the trays, checking the nozzles, making sure there's generally there's always a steam supply valve that should be functioning properly. If you're constantly running your deaerator at 7 psi, but the temperature never gets anywhere near 225 or so, that's generally a sign that the condensate's going in the wrong place, because it has to go in. The condensate that's below 212 has to go in with the feed water, and that's where the steam comes in and heats it up, and it gets out and gets rid of the oxygen. So if your deaerator's running low, it's probably not necessarily your steam control valve. It's likely to be the condensates, the cool condensate, we'll refer to as pump condensates, going back in going to the wrong place in the deaerator. But occasionally those PRVs do fail, and so if the PRV isn't maintaining a constant pressure, particularly if it's going up and not returning very quickly to its set point, that's a sign that needs to be going through. There's probably ports in it that are plugged up that are causing that.
Okay.
So those are some of the things. Preventive maintenance, make sure the DA overflow, the flow is working.
Yeah.
Those get stuck frequently.
Right.
Or the ball breaks off. So those are some of the things that you could look for from a preventive maintenance standpoint.
Sure. As far as logs, we talk about that a lot, to actually use those. What type of things, Gerald, would you log in that situation?
Well, you can log temperatures and the differentials, making sure that what normal is and what your expectations were.
Mm-hmm.
But like you said, a log is only as good as someone actually doing the job.
And yeah, people can definitely do that.
Which is why we recommend third-party preventive maintenance things to make sure that safeties and so forth are getting looked at properly. Because it's the nature of most people when they're walking around it every single day, they start missing what they should be seeing. because they're so used to seeing it over and over and over. So it's definitely helpful to have put some new eyes on it and
Right.
different focus.
Right. Nate, a little bit about blowing down a system. Maybe talk a little bit about that and how important that is.
So anytime you're bringing water into the system, if you have any solids or anything in there, it's going to sink and settle at the bottom. On condensate receivers and DAs, boilers, anything, you want to get that out. You don't want that in there. But it can also, if you don't get it out of the bottom, that's where all your control lines and everything, they come off the bottom of these tanks usually. All that stuff starts getting plugged up as well. Then, your sight glass is kind of fooling you. It's not responding like it should be. The makeup water, when it comes in, it may not be reacting like it needs to be. And that was one thing I kind of wanted to talk about. Everything needs to work as intended on these things, because if the makeup water doesn't start coming in when it should and it gets delayed, well, then it's going to come in a surge. And maybe that PRV or the pressure reducing valve for the DA, maybe it wasn't sized to be able to flow that much steam to keep up with that much water. And as soon as your pressure on that vessel goes to zero, you're not deaerating anymore. You're not removing the oxygen anymore. And I've seen that happen at places where they had the temperature and pressure on the tank when you looked at it. But then if you sat there and watched it run, water would come in, and it was coming in such a surge that the pressure on the tank would go to zero. Well, then the temperature would lower a little bit, but maybe they had some traps or something leaking through too. So then shortly after, the temperature of the tank would rise back up. And so then if you didn't sit there and watch it run, you wouldn't see everything that was happening. And I guarantee you, if you check the oxygen level in there, they had a lot of oxygen in their water just because every time it called for water, the pressure on the tank would go to zero. But when you walk in the room and look at it, your temperature and pressure were okay as long as it wasn't calling for water at that time. So it just depends on how your cycles happen and what all you got going on.
Yeah, that's one of the things you should not see on a deaerator. It's a sign of some big problems. There's generally a vacuum breaker in the form of a check valve on the end of the deaerator. And you should never see that routinely puff out a little vapor. That means that the deaerator is going into a vacuum, which means that the steam is being quenched at a quicker rate than it can be delivered, usually because the makeup valve's too big, not sized properly. And to your point, the water that's going in there has got a lot of oxygen in it. It's not getting the oxygen out of it. The other thing to look for is that the vent on the deaerator should have kind of a lazy plume of steam come out of it. If it's blowing out, then there's a orifice in the top of the deaerator that should be sized for about 0.2% of the deaerator capacity, just to let the oxygen out, but not any excess steam. And so awful lot of deaerators don't have that feature in it. They've just got an isolation valve that's fully open and it's steam blowing out all the time. You're wasting a lot of energy.
Or worse yet, it's fully closed.
Yeah.
One of the things that I would just look at whenever I was in the field, and it's not a telltale sign, but it just kind of gave me something more to go look at, is not even opening the DA. If I knew that the sight glass on it had been changed very recently, and as soon as I walked in there, that sight glass was orange, it's iron that turns it orange. That means the iron's being leached out of something somewhere. Maybe the boiler, maybe the condensate return lines, or maybe the tank itself. But as soon as I saw brand new sight glass on there that maybe it's only there for a couple weeks and that thing's already orange, I could tell right then something's not right.
Yeah. Bill, with you being obviously on the valve side, the pressure relief valves and how important they are, that they're not neglected.
Yeah, on the deaerator.
On the deaerator.
Yeah. They generally only get looked at once in a great while.
Yeah.
Sometimes once every 5 years is kind of the industry standard. Sometimes they don't get looked at that. There's two things about them. One, they're in an environment where they can get a lot of moisture and a lot of corrosion can happen in that in the internals of that safety valve. The other thing that people don't realize is that the safety valve has to be sized for the greater of the steam valve delivering steam to the deaerator or the bypass. Okay, and we frequently see that the bypass around the pressure reducing valve is a full size valve, which is probably much greater capacity than what the safety valve can relieve.
Yeah.
And so you need to have someone look at the sizing of that bypass valve in comparison with the pressure reducing valve and make sure that the safety valve can actually relieve all that pressure. And a lot of times, particularly in the big deaerators, there's a small sentinel valve.
Mm-hmm.
Say, for instance, safety valve may be set at 50 psi for the deaerator. The sentinel valve will be set at 25.
Yeah.
And that's there just to let you know that, hey, there's a problem with the deaerator. If it starts going off, you know you've got an issue.
Sure.
But that's on the bigger deaerators. That's kind of a common feature.
Right. Right.
But the deaerator valves, they're hard to get to. They're hard to take off. Usually there's a lot of rigging involved, so people don't generally want to look at them, but they need to be looked at least every 5 years.
Mm-hmm. What about while we're on topic of safety valves on boilers, how long should they be looked at? You know, how long should it go past the time?
I'm a proponent of doing them every year and tearing them down for two reasons. That boiler has a tremendous amount of stored energy. For instance, a 100 horsepower boiler, actually, a boiler horsepower is different than a mechanical horsepower. So you tend to think of, you know, like your car has 400 horsepower, okay? Mechanical horsepower has 2,540 BTUs of energy. Boiler is 33,000. So it's 13 times greater horsepower than what is a mechanical horsepower, what it's referred to as mechanical horsepower, like you have in your car. So that gives you an idea of how much stored energy is in that boiler. So you want to make sure that it's released properly.
Yeah, yeah.
It never gets overpressure, and the only way to ensure that is to disassemble the valve on an annual basis, inspect it, repair it, and test it.
Mm-hmm.
It will save you money in the long run because safety valve parts are very expensive. If you wait every 2 or 3 or 4 years to repair them, you're going to be buying a lot of parts. The labor to repair the safety valve is not all that great.
Yeah.
And they're repaired to a known standard. But if you wait 4 years, not only are you putting yourself and your operator, your planner at risk,
Yeah.
but you're not saving anything. It's going to cost you more in the long run.
Sure.
So, annually is really the best bet.
And are you releasing, on the relief valve? Are you popping it all the time? Just check and see if it works.
Oh, you mean as an owner, as the
Yeah,
operator? There are inspectors that like people to do that every month. And I don't feel it's really necessary if it's being repaired every year because it's being taken back to the manufacturer's original standards.
Mm-hmm.
But there are inspectors that like to see that, and it's wearing out the valve. So there's a chance that a little piece of scale or whatever will get caught under that seat and leak, and then you're off repairing it.
Yeah. Yes. Yeah. Yes. Definitely checking them annually.
It's good for business.
Yeah. Yeah. I was going to say. Yeah.
Some of the better practices are, we've got a lot of our customers that have a set aside each year. They swap it out, send the other ones back, and always have a rotation of these two sets.
Sure.
That's one of the better practices that we see.
Yeah. Yeah. Makes sense. You know, you guys out there, they use Chat GPT for all this stuff. We have Bill Fogarty GPT. You can hear all of the different formulas and the knowledge that is instilled in that brain. So that's why we're not going to let him go. He's going to retire, but we're going to have that phone. So, well, something I know that is very, dear to our heart, and that is education and training. That's something that is important to us with our our WARE Boiler University. We obviously do that for internal, but we also have that for operators, maintenance people, salespeople, engineers that come in, and we do talk a lot about this stuff. But Gerald, maybe talk a little bit about just the education and training of personnel.
Yeah, I mean, the school was originally designed, and still to this day, we talk about everything from water in to steam out or hot water delivery, whatever the case might be. And we touch on all levels of componentry, all the proper way to maintenance and to do your logs and preventive maintenance. We even, this school will get hired as well to do SOPs for companies. Because a lot of times they're lost on, what should we be doing? What should our operators be doing each day, each week, each month? That kind of thing. And so we'll go out and write procedures for them and make sure that things are getting done the way they should be getting done, and they do it in a safe manner. So there's a bunch of different courses to choose from whether it be you're doing your open and close or your controls or your combustion, just a whole litany of things with safety being a major focus.
Yeah. Is monthly safety meetings in this situation, in these situations, in these plants, is it something that should be conducted?
Well, I mean, we have safety training every month.
Yeah.
In our right here at house. So
Yeah.
I would hope that everybody's doing something monthly to increase the awareness.
Yeah. Your thoughts?
Yeah, absolutely, and particularly with the boiler operators, because they're many times it's hard for these guys to find a qualified operator, and so they're pulling somebody off the production floor to run the boilers, and this many of those people don't have any appreciation for how much stored energy is there, how quickly things can go wrong.
Yeah.
I was at a plant yesterday where they used to have 3 operators. They're down to 1. So he's working 40 hours a week. So the plant operates around the clock. So nobody blowing down boilers. So that's just a lot of risk.
Yeah.
So they're definitely to pull people in off the floor who don't have an understanding of it. That there has to be training. It's not a good place to be.
Yeah. In those safety meetings, you're talking about the early warning signs, that they should be seen and they should be recognizing as they're out there working, that it's not just a mindless job of, hey, go do this, go turn that, put that log in, whatever. It's truly looking and identifying what those potential signs are before failures. And those things could be talked about on a monthly basis of a lot of different things.
Yeah.
Right? I mean, and slowly the person becomes more and more educated.
Yeah, the experience operator walking to the boiler room, he knows he has a problem because he's hearing a bearing go out on a pump or a motor blower.
Yeah.
He can feel the vibration.
Yeah.
He knows I got a problem coming.
Sure.
See something new leaking, and that only happens if a guy's there all the time. It doesn't. A new guy doesn't necessarily look for those signs.
Right. Well, go ahead.
That's one thing I would tell a lot of people that were coming into the boiler room is like, you need to spend some time in here. You need to learn what is normal, what's not normal. And with the safety side of that, if they see something that's leaking, and it just always leaks, that's just normal. Having those safety meetings, they can find out that's not normal. That's not supposed to be happening. We need to do something about that. But and then just like you said, with the bearing and stuff like that, you learn, with the way the room sounds, the way it acts and everything, and you find out what's normal and what's not. Then you can walk right in. You'll know something's wrong right away. But I couldn't tell you how many times I've questioned, a person at a plant about the way something's working. In my head, I already know it's not right, but I'm just asking, like, when did this start? Oh, it does that all the time. That's normal.
Yeah.
I get that it does it all the time. And no, that's not normal.
For sure.
And there are a lot of simple things to monitor, particularly as it relates to a boiler, like your temperature gauges and so forth, and keeping up with the fact that it's supposed to be at a certain level. And if it's going out of range, there is a problem. It needs to be addressed. Something's not being done correctly. So having those things in place. And then there's so much great automated information now that will give you alarms and so forth that I think is getting more and more adopted just because they're having a more difficult time out there getting their people up to speed and trained because so many old people like us are leaving.
Yeah.
So,
Well, when the proverbial crap hits the fan, that's when things can get
gets plenty of attention.
but it also can either get shut down quickly to where nobody gets hurt, right, if somebody's there. And so maybe speak a little bit about how important it is to understand an emergency situation happens on how to really just shut down procedures, right, to do it right.
And there's a variety of things. So, and there's different procedures for everything, whether it be gas line, getting to the mains, your emergency shut off E-stops, where you're shutting it off while you're leaving the building. Sometimes the best time to shut it down is when you're not around.
Yeah.
You got to be careful.
Yeah.
Probably the one that worries us the most is when the boiler runs out of water. And the first, an inexperienced operator will want to add water to it quickly. It's just the wrong thing to do. And they can go into more detail on what the procedure is. But if a boiler is way below its normal water line, you can't see anything at the sight glass. That's not necessarily the time to add more water because that you add the water and if it's empty, it can explode. And you can probably solve more on that.
That's one of the great things about having, boiler e-stops or boiler room e-stops. You don't want to be, if you've been firing a boiler with no water in it, you don't want to be anywhere near it because you don't know why it doesn't have water in it. And whatever's been preventing it from getting that could stop preventing it and all of a sudden send it to it, whether that be a bad contactor or a bad float or something like that. You don't know why. You don't know why it's doing this. You need to shut it down, hit the e-stop, and you need to get out of there. Give it time to cool down because you don't want to be anywhere near it while it's glowing red hot and all of a sudden water finds its way to it.
Yeah.
Yeah, the E-stop's at the door for a reason.
Yeah. You don't want to have to go to the boiler to shut it down.
Right.
You want to be going the other direction.
Absolutely. Well, I know there's some proper documentation, and we're getting into paperwork, so I'm going to just throw this out here, and whoever wants to tackle some documentation, you can maybe jump on it.
Well, on the safety valves, you need to have the last test reports when they're repaired. The inspectors will generally want to see that. They'll be looking to make sure that it has a VR stamp on it, which means it's been repaired in the National Board of Pressure Vessel Inspectors VR program, meaning that it's taken back to the original dimensions, original parts were put back in it. So they have a pretty, it's a way that the inspector can know, okay, somebody who knows what they're doing has been through that valve. I don't have to worry how well it's been repaired.
Right.
So that's one of the first things they'll look at. But other than daily logs, they'll want to see daily logs.
Sure.
Dating back.
I was going to mention about the daily logs. Gerald had mentioned before, a lot of times they'll start getting pencil whipped. And, well, I'll go back to what's normal and what's not. If you're pencil whipping all of your logs, you're not seeing if something is no longer normal.
Right.
And, that could be anything. That could be stack temperatures. That could be your oxygen levels. That could be your pH. Could be water hardness. Anything. And I mean, I've seen, a lot of them, they'll even write down, what the firing rate is, because they're going to log the time of the day and time. So write down what the firing rate is. And if you've been doing it, every day at noon and it's been running at 35, 40% firing rate for the last 3 or 4 months, now all of a sudden it's running at 60, you haven't changed your process, it's telling you there's something going on here. This isn't normal. Why is this happening? And, some places get really in depth and they can catch things from multiple angles. They watch how much fuel is used per day. They watch how many gallons of water that they make up per day. And that's a great one. If I've been making up this amount of gallons of water per day and all of a sudden that goes up, water's going somewhere. We've got to figure out what's wrong. You can really catch a lot of these issues early on with those logs. But
If you accurately trim, yeah.
yes, that's exactly what I was going to say.
And the other thing to log is, which a lot of people don't, is the condensate return temperature.
Sure.
Because then you'll know if it's normally coming back at 80 degrees and suddenly it's 200, you've got failed traps.
Yeah.
Somewhere.
Yeah.
And if you're running that into a vented receiver, just a feed water tank, if you get above 200 degrees, pumps don't like it.
Yeah.
They stop pumping as well, and you lose seals.
Sure.
So that's a great one to log every day. Most people don't.
Yeah.
But it's an early indication that you got problems outside of the oil free.
Right. Right. That's, being accurate with this info and diligent on what you're doing, because in a case like this is all going to be scrutinized in court. So doing it right, is so important. And you're not pencil whipping, because there could be a time when something like this happens that all of a sudden you've got to vouch for what went down.
Right.
And it's so important. What are some of the, maybe just some compliance associations, ASME, things like that you want to make sure that they are abiding, to those?
Well, the ASME is a broad standard for all kinds of different things. So and most of it falls back on manufacturing of the kind of equipment.
I mean, you got OSHA.
You got OSHA for your safety compliances and so forth.
Yeah, NBIC.
Your national wear inspectors. And then you got your AIs from your insurance companies that weren't certain things compliant, whether it's FM or just from blank on who's UL. UL. So you got all those different compliances.
Right.
But that's products that are coming into your facility being built in a certain way. But to that point, there are times where someone will come in and install a tank or something like that, not really understanding what it's for and what it's doing, and it gets put in a pressurized situation when it wasn't supposed to, or safety wasn't put on it like it was supposed to, and then you can be back to these kind of explosions again. And that's one of the reasons why the non-fired vessels have the most explosions, is someone inexperienced is putting it in a situation and there's an orifice up there, and they just put a valve on it so whatever gets in there doesn't leak out, when it was intended to have a safety relief valve on there.
Yeah.
And they just don't understand.
Yeah.
So you got to be careful when you're working in these environments. And a lot of the process environments have pressurized systems. I mean, that's just the way the world turns.
Yes. 100%.
Yeah, the other thing it's important, if you're adding to your system, most steam systems were at one point in time engineered. The condensate systems are typically assembled rather than engineered. Most of the time, the problems in the steam system is on the condensate side. 9 times out of 10, they have a problem with the steam system. It's actually on the condensate side. So it pays to have an engineer design the condensate system and the steam system you'll spend so much less money over the years if you have a properly designed steam and condensate return system. And then keep in mind that the life expectancy of a condensate return system is only 20 years. It's Schedule 80 pipe, and the corrosion allowance on it means that after 20 years, you should be looking at replacing that. In steam systems, the life is typically 40 years. So if you're operating a steam system that's got 80 years, built 80 years ago, you're on borrowed time. Something is going to break.
Yeah.
And when it breaks, have an engineer come in who's familiar with steam and provide the solution. Don't go patching it. You're going to spend way more money in repairs and downtime than you ever would for the engineering.
Right.
So
Right. Awesome. It's a great discussion. Make sure you're maintaining up-to-date documentation of all the inspections, all of those repairs, and replacements to avoid gaps and like just regulatory oversight, right? Mm-hmm. So, well, this is a wake-up call. This type of a case right here gets a lot of attention, but it is a wake-up call to all the plant operators, safety personnel, anybody that's working with, pressure vessels, boilers, steam systems, or whatever it is, is you can really take this story and go back, double check your maintenance, make sure that things are being done right, your people are being trained, that you have the proper paperwork, and put this at the forefront to make sure that you're doing the right things. I mean, that's something that is so, so important out there. The systems are, this is not just boiling water. As you could hear a lot of the discussions and you hear just the formulas and just the technical piece of this, and every system, it seems like it's different. It's really interesting to be around, people and that have all these experiences, to hear all the different ways, and you only get the type of experience being around for 100 years, right, Bill? But we appreciate you hanging out with us, and hopefully you learned something, and make sure you tune in next time, on our High Fire podcast. Share these videos for us, and we'll see you next time.